Welcome to another video by Mr. Brash. That's me, I'm Mr. Brash, and this over here is Mr. Squirrel joining us for today's video, and we're going to talk about the equation of a circle. Now, most of us should know the equation of a line, y equals mx plus b, and all shapes and sort of 2D objects need to be able to be described in math using equations somehow. And a circle is very difficult to draw for a computer or for a hand even, because it's actually made up of a minuscule amount, or an infinite amount rather, of dots that draw the edge of a circle that's actually made up of a line. So if we had a line segment that went from the center of this circle up to the edge here, I've got this dot at 2, 3, that draws something that we know as a radius for the circle. And if we plant the origin here and we say we're not allowed to move that, that's like planting a pencil or a pin. We'll put a pin in it, right? And if we had a pencil at the end of my radius arm here, and that's what I've got written here, a circle is drawn using that radius arm. Imagine a string. So my blue line here is a string with a pencil at the end. So I've got this pencil at the end, and I'm going to swing that around, and it's going to draw the circle. And me talking about it is all well and good, but let's get a demo. So here I've got this point B, and I've got a radius arm, this purple arm, that is a length 6. Now watch what happens when I swing my B around, and I'm going to leave dots everywhere I go. If I go really fast, it separates the dots here. And we can see that as I go around, the more dots I draw, I get a circle. And if the dots are nice and tight to each other, I get a really beautiful circle. But if the dots are a little bit far away, I get, a dotted sort of circle edge. But everywhere I go along this circle, I've got a radius of 6. And for the entire video here today, we're going to be talking about circles that are centered at the origin. They're actually not very difficult if they're not centered at the origin. It's just easier to talk about it this way. Now, how do we discuss this using an equation? Well, I've got another circle here. It's going to be a little bit smaller, where my radius is 3.6, and it's kind of hiding on the x-axis. Watch what happens when I bring this radius arm around. What I end up getting is this height and this width. So I've got a right angle triangle being drawn here inside my green circle. So as I go around, I get what's called a triangle inscribed inside the circle. And everywhere I go, this right angle triangle's height and width are changing. But the radius is always staying the same. The radius is always 3.6. And what do we know about right angle triangles? So I'm just going to stop it here at the same point that I have on my other document, 2, 3 here. I've got a height of 3 and a width of 2. I can use a tool that we should all know at this point to get that radius length, and that would be Pythagorean theorem. And if you know the equation for the length of a line segment, Pythagorean theorem and the distance equation are directly related. So we know of Pythagorean theorem as c squared equals a squared plus b squared. And we also know the distance equation as d is equal to the square root of delta x squared plus delta y squared. And that's from the Pythagorean theorem, because if I wanted to write this a different way, I don't have to write the square root. I could say d squared equals this stuff. Well, the radius of a circle is no different. As a matter of fact, the equation of a circle is no different, where we're going to say that the radius arm is going to come from Pythagorean theorem, where I can get the difference in the height of this line, which in this case is 3, and the differences of the horizontals in this line, which in this case is 2. And I say differences because I would do 0, take away 2, and I get 2, or 2 take away 0, I get 2. And I would do 0 for my height, take away 3, or 3 take away 0 to get my height there for 3. And we know that equation already. It's the distance equation. So my radius is the square root of my delta x's squared and my delta y's squared. And this gets kind of confusing. I wish mathematicians didn't use distance, because that looks like diameter. It's not diameter, it's more like length. So back in my classroom, I typically teach the distance equation with an L for length so that we don't confuse it with diameter. Now what we're going to do is we're going to write this equation a little bit differently. We don't want a radius equaling a square root of all this stuff. We're actually going to square both sides. We're going to write it like Pythagorean theorem. So we're going to say r squared equals the delta x's squared and the delta y squared. But because we're always centered at the origin, we don't really need to worry about the deltas. Because if I take my delta or my difference, I'm not subtracting anything. I'm subtracting 0. Nothing's happening. So my radius here is 3.6. And how do I know that? Well, I know that not only from the demo that I did before, but because my x is going to be squared at 2, my y is going to be squared at 3. That gives me 4 plus 9, which is 13. And then I'm going to have to square root both sides. Well, the square root of 13 is 3.6. And so I know that my radius is 3.6. And if I know my radius is 3.6, and I know that my center of my circle is always going to be the origin, I don't really need to write anything else. I just need to know that the radius is all that matters. So a radius of 3.6 squared came from my delta x, which was 2 take away nothing. So really that's just 2. And my delta y, 3 take away nothing, which in this case was really just 3. But I'm not going to write 2 and I'm not going to write 3. I'm going to write x and y. How come? Well, because the point's not always at 2, 3. I could have drawn this point over here. I could have drawn this point here. I could have drawn this point here. And that's the whole point, is I don't know what the x's and y's are going to be as I go around this circle. They're going to change. But the thing that's going to stay constant is the radius. Now 3.6 squared actually came from 13, so I don't need to write it with its rounded decimal value. I know that 13, if I square root 13, I'll get the radius. And that's a big confusing portion of this sort of lesson, is that the radius is not 13. 13 is if I square the radius. So we should do a couple examples here to make sure that we're on the right track. But what you need to remember is that the equation of a general equation of a circle is that the radius squared is equal to x squared plus y squared when the circle is centered at the origin. If it's not centered at the origin, you're going to have some deltas here. You'll subtract the center. All right, so our first example, and it's going to be centered at the origin. We have been asked to write the equation of a circle with a radius of 7. So my radius is 7, but my radius squared is not going to be 7. My radius squared is going to be 49. And the equation of a circle is radius squared equals x squared plus y squared when centered at the origin. So my equation of this circle is 49. 49 equals x squared plus y squared. That's all we have to write. Because looking at this, I know my radius is 7. If I wasn't given that information, I go, oh, the square root of 49 is 7. And that's my radius. And so that radial arm will swing around and draw a circle for me. Now, what if my radius is square root of 5? So the square root of 5 squared, right? My radius is square root of 5, but I'm going to square it. So how do I square the square root of 5? Well, square root and square cancel each other out. And so my radius squared is actually just 5. So my radius squared is just 5. And so my equation in radius squared equals x squared plus y squared is just 5 equals x squared plus y squared. And again, that's because I squared my radius. Now, if I've been given a diameter, my diameter is 10, but that doesn't help me out very much with the radius. So radius is half my diameter, which is 5. Not to get confused with the 5 in the previous question, because this one's not square rooted. So if my radius is 5, my equation of the circle would be 5 squared, because radius squared equals x squared plus y squared, but I'm not going to write 5 squared, I'm going to write 25. So the equation of this circle is 25 equals x squared plus y squared, knowing that I'm going to take the square root of this to get my actual radius to draw the circle. Let's take a look at another example here. So I've got this circle, x squared plus y squared equals 36. And I've been asked to state the location of the center. Well, I know the center of this circle is at 0, 0 because I don't have any deltas going on with my x's and my y's. State the radius. Well, this would be the square root of 36 to get my radius. So the square root of 36 is 6. And we're going to be talking about square roots a little bit more in just a minute because it gets a little bit more complicated. Okay, state the diameter. Well, diameter is just 2 times my radius, so that's not too bad. Now state the x and y intercepts. And to state the x and y intercepts, I'm actually going to move on to the next one, which is graph the circle. So I'm just going to sketch myself a little Cartesian plane here. And it's, again, just a sketch. But my x and y intercepts are going to help me graph this circle. If I know I've got a radius of 6, that means that no matter where I go, my radial arm will have that length of 6, meaning I'm going to cross the x-axis at 6 and again at -6 over here. And I'm going to cross my y-axis at 6 and again at -6 down here. And if those are my x and y intercepts, that's going to help me draw the circle, because now all I have to do is connect those dots, which is a little bit easier than it sounds. It's actually pretty difficult to connect those properly, especially when you're just doing a sketch like this. So you would connect your dots with a curved line to try and draw a circle. And I'm not the greatest at drawing circles by hand. It's actually quite difficult. You give me a big chalkboard, I can do it, but on something like this, it's not as easy. And so that's my answer for E here. That's my graph of the circle. And now it says to find a point on the circle other than the intercepts. So I already know the intercepts. I'm not allowed to use those. I got to find a different point. Well, if you remember back when we were doing graphing when we were younger, we get to pick the x values that go on the circle or that go on the graph. So if I just pick any old x value, so let's just pick a random x value here. I'll pick an x value of 4. Let's pick an x value of 4. So I'm going to have a point up here that is going to be 4 something, and I'm going to have a point down here that is going to be 4 something, because that radius arm is going to hit both up top right here and also down here as it swings around. So we need to discover what those y values are. So we're going to go back to our equation of 36 is made up of x squared plus y squared, and I'm going to plug in my 4 for my x value. Just going to do the math on that. 4 squared is 16. Subtract the 16 on both sides, and I get 20. So y squared is equal to 20. So what I need to do is I need to take the square root of 20. And the square root of 20 is actually going to give me 2 different answers. In order to discuss that a little bit better, let's just go off to the side and say, what is 3 squared? Okay, well 3 squared is 9, but what is -3 squared? Well, that's actually also 9. So if I was going to ask you, what is the square root of 9? Which one of these 2 answers do you pick? You actually have to pick both. It's positive or -3. So the square root of 20 has 2 different answers, a positive and a negative. And in this case, the square root of 20 is 4.47. So we've got a positive and a negative 4.47. So up on my graph here, I'm at a 4 and a positive 4.47. I'll just call that 4.5. And a negative 4.47, or a negative 4.5. And apparently I'm changing my colors all willy-nilly here. So let me just retrace that. That means that my y values of that point are positive or negative 4.47. So I did find a point on the circle. As a matter of fact, I found 2. I found the point 4, an x value of 4, and 4.47, and 4, negative 4.47. I actually went above and beyond finding 1 point. I found 2 of them. Now this might make a little bit more sense after the next example or question, or it might even confuse us more. So here, let's just change this to a square root of 11. Okay, so determine the values of a if the point a square root of 11 lies on the circle. All right, so determine what a is going to be. So my equation is 36 equals x squared, so in this case a squared, plus y squared, or in this case the square root of 11 squared. Square rooting and squaring are going to cancel each other out here. So 36 is equal to a squared plus 11, because I squared my square root. I'll subtract 11 on both sides, and I'll get 25. But that's what a squared is equal to. If a squared is 25, when I take the square root of both sides here, so I'm going to have to take the square root of 25 and the square root of a squared. Squaring and square rooting cancel each other out, so I get a. But on the left-hand side here, what gave me 25? Because 5 squared is 25. But so is negative 5 squared. That's also 25. So realistically speaking, my answer has 2 values, positive and negative 5. So my values of a could have been positive 5 or negative 5 for this value when I'm on a circle. And that kind of makes sense because there's 2 spots for every y value and there's 2 spots for every x value on a circle. Okay, moving forward here, we've been given some information that a circle has a center at 0, 0, and it passes through this point 5, negative 6. Give me the equation of the circle. Well, here's the equation of a circle. It's r squared equals x squared plus y squared when centered at the origin, and thankfully this one is. So I have an x and I have a y. I'm going to plug those in. So r squared is equal to x squared, or 5 squared, and y squared, negative 6 squared. So my r squared is equal to 25 plus 36. So my r squared is 61. And that's my r squared value. I don't need to bother square rooting both sides because my equation of a circle is r squared equals. So I'm going to leave it r squared, 61. So the equation of this particular circle is 61 is equal to x squared plus y squared. And now I can put in any x value I want and figure out what the y value is to draw this circle, which is exactly what the computers do. Next up, it says, what is the distance around the circle? Okay, well, the distance around a circle is known as circumference, right? The perimeter rather of a circle. So it's pi d, pi times d. Well, I don't know the diameter, but I do know the radius, right? The radius is the square root of 61. And the diameter is 2 times my radius. And my radius is the square root of 61. So thankfully I have a scientific calculator here, and I'm just going to say 2 times the square root of 61, and I'm going to multiply that times pi. And I got almost exactly 49. And in this case it's just units. We don't know what the units is for this question. So because the diameter is 2 times the radius, and my radius has to be the square root of 61, this is the math for that question. Next up, what is the area of the circle? Okay, well, area of a circle is pi r squared. Well, I already know what my r squared is. That's part of the equation. My r squared is 61. So all I have to do is take that r squared value and multiply times pi. And I got 191.6. So approximately 191.6 units squared for the area of that circle. Last but not least, we're going to determine if a given point is on, inside, or outside a given circle. So here's my circle equation that I've been given. And this is actually a little bit easier than it sounds. If the point that you've been given is actually on the circle, the equation will work. So you're going to plug your values in for x and y, and you'll get 60. So let's try this out. Negative 5 squared plus negative 6 squared. Does that equal 60? We're basically asking a question here. Well, this is 25 plus 36, which we already saw in the previous, is actually 61. So 61 is bigger than 60. So if I was to plot this point, I'd get a radius larger than 60. So this point A here, that is outside the circle. It's gone past the circle, kind of like the atmosphere for our Earth. In the next one, we would plug those values in. So negative 7 squared plus 3 squared. We're going to see if that gives us, I put 9 instead of squared there. We're going to see if that gives us 60. Okay, so that's 49 plus 9. Does that equal 60? That's actually less than 60. That gives us 58, which is less than 60. So this point is inside the circle because that would give us a shorter radius. And by process of elimination, you'd say, okay, well, the next one's going to be on the circle, and you're probably right, but let's just check it out. So 6 squared plus negative square root of 24 squared. A little bit of a complicated thing here, isn't it? Is that equal to 60? And thankfully, you have a scientific calculator if you're not sure how to get the square of negative square root 24, but this is 36. Squaring a negative just makes it positive, so there's nothing particularly scary about that. And then squaring cancels out the square rooting. So that's just 24. A little bit of a trick question there. And in fact, 36 plus 24 is 60. And so this point is on the circle, whereas the previous points were not. So a little bit of a whirlwind of a video here to describe the equation of a circle. Give yourself some practice questions, find some practice questions somewhere, discuss the equation of a circle. And again, this is for when it's centered at the origin. I'm Mr. Brash. That was my video. This is Mr. Squirrel. He approves of the video. Leave me some comments maybe in the comment section. Like the video if you want, subscribe. Or, you know, if you've got some constructive criticism, leave that as well. I'm open to opinions. But definitely keep practicing math.